get into the big topic of open source, something that we actually say at Red Hat.
This is so awesome.
We are an open culture that believes in the importance of
What is that process that a developer, or let's say,
as the Kubernetes ecosystem really boomed.
Hello, good morning, good evening, good afternoon, wherever you are in the world. This is the Ask an OpenShift Expert live stream. I'm Jonny Rickard. Andrew is not here. He will actually be here next week. He got pulled into some marketing things, so he's unable to make it this time. But he will actually be here next week. We're going to talk about, we're going to do a deep dive on virtualization and storage next week. So that'll be a good topic. Real quick, we have Dean and Dan from Isovalent coming on. Before you guys do intros, I just wanted to make sure everybody knew who you guys were. Dean, welcome back. We've had you on a couple times, so glad to have you back. And Dan, welcome to the stream. It was nice to meet you, and this is going to be awesome. We're going to have a good time. For those that don't know, this live stream is part of the Office Hours live stream series. It's a way for you, the OpenShift person, to come to us and ask us questions, and hopefully we can answer them. If not, then we typically know the right people to reach out to. If you don't feel like answering the question live, or if you're watching this on YouTube later on, feel free to shoot me an email. I'm Jonny at Red Hat, JONNY at redhat.com, or Sully at Red Hat, SULLY at redhat.com. And we'll do our best to respond to emails. We're both pretty much in email jail most of the time anyways, but if we get the opportunity, we will definitely take your question and pass it on to the right people and get it answered. So with that, we have a couple top of mind things. So Red Hat Summit just wrapped 2 weeks ago. We missed last week because of me. And coming out of that, there was an announcement for Project Lightwell, which is it's a collaboration between IBM and Red Hat to make AI more secure. So there's more to come from that, but just to make the announcement. The other bit of this is June 23rd is the what's new and what's new in OpenShift 4.22. So this is a product release live stream that we do where we go out and we talk about all the things that are coming out in OpenShift and the latest version of OpenShift. So we just finished what's next a couple weeks ago, and now with what's new, that's right on the tailwind of the latest release of OpenShift. So lots of good things coming. And next week we're going to talk about something that I've seen it in the UI before, but I've never actually played with it until this week. And so we'll talk about that a little bit too, which is the basically it's the sudo within OpenShift, which I think is freaking awesome. So yeah, we'll check that out. Okay, now that I've just burned through that like I've had 8 cups of espresso, I'm going to pass it back over to you, Dean. Let's go ahead and introduce yourself.
Yes. Hello, everyone. My name is Dean Lewis. I'm one of the technical leaders here at Isovalent, and I've got my colleague, Dan.
Hello. Yep. So I'm part of the community team here at Isovalent, focusing on kind of all things open source, helping people get to grips with everything that we're doing in the world of open source and community.
Awesome. So let me go ahead and turn this on.
Yeah. So as Jonny mentioned, we had Red Hat Summit a couple of weeks ago, and Isovalent were there. So some of you listening to the stream today or the recording probably came by and spoke to our booth and spoke to probably Marcos, who was chatting to a lot of people. We have Cisco Live this week as well. This is just like perfect timing when we booked this with Jonny, though this was not planned at the same time as well, but I think it is very timely. And ultimately, one of the technology areas we've been focusing on is taking away the pain of the networking side of cross-hypervisor migrations with a component called Isovalent Network Bridge, which is part of a wider solution, which we've officially GA'd yesterday at Cisco Live, which is called Isovalent Networking Virtualization. Myself and Dan, we've done quite a few talks and demos on this. It was front and center for our piece of Isovalent being at Red Hat Summit a couple of weeks ago. So again, it kind of ties in, like I say, I spoke to Jonny, we came on to speak about that today as well. So yeah, I guess we kind of, we're going to do this as a little bit of like a question and answer session as well as we kind of go through that. But I think first and foremost, you probably already get a little bit of a hint of what we're going to talk about today in terms of what we mean by cross-hypervisor migration. And before we dive into kind of the tech side and a couple of slides showing architectures and then some demos that we've got as well, let's talk a little bit about what we're seeing in the industry at the moment. So I think it's very prevalent. Red Hat's doubled down on OpenShift virtualization for a particular reason. And that's because in the technology industry at the moment, there's a little bit of flux going on. So, of course, VMware was acquired by Broadcom, I think 2+ years ago now. And there's a number of customers that have started to reevaluate where they sit in the market and the hypervisors that they use. And also, what does this mean when they're looking at maybe taking on cloud native type technologies and public cloud technologies as well? So it's not just that acquisition that's kind of forced them to rethink this. It's a lot of things all happening at the same time. But unfortunately, as we know, when you have a large estate that's based around one particular technology, like a traditional virtual machine hypervisor, you're typically bought into an ecosystem with that. And it can be really hard to move away from that ecosystem. And over the last 12 to 18 months or so, we've been working with our customers that want to migrate to a technology predominantly like OpenShift virtualization, which is based on KubeVirt under the hood. And they want to bring their virtual machines to sit side by side with containers. And that's what we're here to talk about today is how do you actually make that a reality? Because I think if we take a quick point in there, and I'm going to throw it over to Dan on the spot, but what's the main issue today when you run a virtual machine in KubeVirt?
Yeah, I mean, there is, as you mentioned, a big a stampede almost at this point in time of people hitting a upcoming renewal in their existing platform and looking kind of moving over to other platforms. And people are kind of running quite quickly with this, but ultimately there are caveats to, well, there are always caveats to moving from one platform to another. From the perspective of what we're seeing, largely it's the one, there's kind of multiple caveats, but many of the main caveats are, one is having those two different types of workloads sit side by side in a way that makes sense. And two is the migration of those virtual machines into a cloud native environment, which gives them a huge raft of benefits from all of the cloud native technologies. But what people are finding is that also that is breaking to a certain degree the traditional model, the traditional networking model in terms of how things existed prior. Typically in a existing environment, kind of quite flat layer 2 networks, your VMs all sat on /24s and everything was kind of easy peasy. And things like those layer 2 IP addresses, those were the identity of those workloads. And that goes 100% against the grain of the cloud native model, as it were. I'm not a big fan of the term the old cattle and pets sort of thing, but the idea really is that in cloud native workloads, they spin up, they spin down, they scale, they shrink. And ultimately, whether it's workload 3 or workload 300, to me, the end user, I don't really need to know who it is. And I don't really need to know about its IP address and its identity as such. Those higher level cloud native abstractions that sit on top of all of that, they hide all of that complexity from me, the end user, from me, the network admin, and from me, the data center architecture and things like that. So, as mentioned, moving from one kind of paradigm where the IP address is king to an environment in cloud native where those logical architectures are now king, mean that kind of what do we do? How do we address that? So you've got that kind of issue, but then you've got, I want the benefits of cloud native kind of attached to those, singular identities. I want networking policies. I want to find a way of having, kind of that load balancing technologies, the access to things inside the cluster to outside the cluster, all of those sorts of things as well. So I think, these are kind of the issues that people are seeing when they're migrating. The technologies, the mindset changes, the architecture and layout of everything suddenly all changes. But ultimately, how do I then, get around all of that, or how do I mitigate for that whilst getting the benefits of cloud native architecture? So that's, I think, kind of a high level overview of what people are kind of butting up against when they are migrating and beginning their migration journey.
Yeah, I think that makes sense. I don't know about you, Jonny, but I'm guessing this is one of the issues that Red Hat customers in general are looking at. We've got the Red Hat virtualization piece available, but still, how best to kind of adopt virtual machines running side by side with containers is kind of like front and center of people's minds.
Yeah, absolutely. And the funny part too is that, like, I think, like, when you think about when OpenShift virtualization first started kind of like coming on the scene, right? We weren't really talking about migrations, really. I mean, there was that aspect of it, like, okay, we're gonna have to migrate off of it, but it wasn't like you said, it wasn't front and center. But I think, as the market shifted for whatever behavioral things happened in the market to force this shift and people migrating off of one platform to another, I think like migration really became a thing. And then when you're talking about IP being king, like that just takes me back to my old data center management days, where it's like, that's how you knew what would where, right? Like, it's like, oh, okay, this is this type of system, so it's going to go in this environment with this VLAN or this this subnet or whatever. But yeah, it's crazy how far we've come, actually. So
100%. I mean, I remember the identity of the network lived inside a spreadsheet. Like if I needed to work out what that VM was, it was typically in a spreadsheet, and the owner of that application would be in there and things like that. Like, who owns a pod? Like, the application people own a pod, and it spins into life and dies and all that sort of stuff. And like, I don't need to scream at anybody else. Another one will spin up, but everything will, cogs will whir and things will happen, and it will carry on working as expected.
Yeah, I think so. I'm going to click through a couple of these slides. So I think for most people probably on this call today or listening to the recordings will know that OpenShift virtualization is based on the open source project KubeVirt, and then Red Hat come and add all of their bits on top of it to bring it into the Red Hat OpenShift ecosystem and add all the components together as well, which is fantastic. But ultimately, under the hood with KubeVirt, there's a couple of kind of like necessary problems that you have out of the box. And these aren't a Red Hat issue. They're not a CNI issue. They're kind of fundamentals how KubeVirt works today as well. For those of you that haven't seen any of these images before, essentially KubeVirt just gives you the additional capability to use QEMU and libvirt in a programmatic way through Kubernetes to run virtual machines on the same nodes that you are running your containers on. It adds an additional number of controllers and operators in place to do that. And ultimately, although we've got kubectl, a lot of people on the call will be using the OC command here. Essentially, you're going to post a manifest to create a virtual machine. It's going to go to the API server. There's a virt controller that watches for that as well. That's going to create a pod for the VM process to launch in. So there's a concept of a pod for a virtual machine inside of Kubernetes itself. Then what happens from there is it goes off to a virt handler that handles that side of it, and a virt launcher, and it will speak to kubelet, as you'd imagine as well. That's the hooks into the Kubernetes side of the house. Kubelet's going to spin up that VM pod, and that VM pod is actually called a virt launcher. So what then happens is, for any virtual machine you've deployed inside of your environment, you will have a pod that sits side by side with it. But that seems quite strange at the moment, because we're talking about running the virtual machine at the KVM layer here with QEMU, and then still that's wrapped in with that container runtime sat around it as well. So why do we need that pod to run a virtual machine? And ultimately, it comes down to the out-of-the-box networking from KubeVirt. So this is my favorite diagram. I've stolen this from the KubeVirt project. And essentially, I'm going to hand it over to Dan just to walk us through it as I point with my arrow.
Yeah, I mean, I think quickly before you do that, if I may, I think it's been interesting because I've been following like the evolution of this a little bit of time, and it is clear that KubeVirt has become the de facto standard for running your virtual machines. There were kind of as there always is, an original demand to run VMs in Kubernetes for quite some time. And before KubeVirt was kind of chosen as the de facto, there were a number of different projects that were all kind of vying for space in here. And one of I thought the more interesting, and I thought was going to be the one that would win, was instead of having a kubelet on your node, which spins up pods, was having, I can't remember the name of it now, but effectively, instead of it being kubelet, it was like KubeVM or something or other.
Is this why it didn't win? Because no one could remember the name of it.
Well, that's, yeah, I was going to say, there we go. Case in point, yeah. Well, good point, well made. But you would basically have VM nodes. These nodes wouldn't run pods, they would run virtual machines. And they would run a different version of the kubelet that was there just to spin up VMs and things like that. But ultimately, yeah, KubeVirt has been the chosen technology that a lot of different vendors have kind of settled on in order to run their virtual machines. And yeah, it comes with its own pods that have QEMU running within them, and the capability of speaking to the kernel to do all the KVM goodness. And yeah, so let's kind of step through the networking architecture here. It might be, I don't know, do you want to go bottom up or top down? It's entirely down to...
Let's go bottom up.
Bottom up, okay. So you have your physical node as part of the Kubernetes cluster. The gray boundary here is one of the many nodes in my Kubernetes cluster that the scheduler has chosen is going to run my virtual machine. And every node within that cluster will have a CNI daemon running on there. In our example, that daemon is going to be Sullivan, and Sullivan's job is to effectively attach a pair of Ethernet devices inside a pod, allowing that pod to speak to the outside world in any way required. So, as mentioned, the first thing that happens is the kubelet will spin up a pod, which is going to be our compute container. Cilium will take care of doing what's known as a virtual Ethernet pair. So that's an Ethernet adapter on the host, a virtual Ethernet adapter on the host, and then a virtual Ethernet adapter within that pod in a separate network namespace. So inside that compute controller, you will see ETH0. And on the other side of that ETH0, you will see the vETH pair, which is on the host itself, which will then send traffic to the CNI, which will send it wherever it needs to go. So inside that compute controller, we then have libvirt, which is another technology which is part of, it's kind of runs alongside kind of like the QEMU tooling. And libvirt really is there to take care of making it easier to use QEMU and things like that. But ultimately, it will spin up things like Ethernet bridges, layer 2 bridges. It will take care of assigning IP addresses to virtual machines as they come up and things like that. And then finally, inside that compute controller, we will have our virtual machine pod, which again will have the networking bridge between the two. That virtual machine will be given an IP address from libvirt. So long story short here, my virtual machine, inside it will have an Ethernet adapter, which is ETH0. When traffic is being sent to my Ethernet adapter, it will go across the bridge to the outside adapter, which is VNet0. Then there will be another bridge to the container Ethernet adapter, which is ETH0. It will go across the next bridge to the other side of the odd virtual Ethernet pair. And then finally, it will hit the CNI, where it will either go to another pod, where it will be encapsulated and sent between pods, or it may be source natted and traffic will go to a address outside the Kubernetes cluster, etc., or wherever it needs to go. So wow, this is the architecture that we're dealing with.
Yeah, and I saw a comment come through in the chat around, does this work the same with OVN Kubernetes? And the answer is, out of the box, yes, because this construct that we see in front of us in this diagram is the implementation from the KubeVirt side. So when you spin up a virtual machine, it creates that in KVM, and it's going to link that KVM networking to use the CNI of the Kubernetes cluster. There are a couple of additional options, so you don't have to use the CNI networking to run that VM. You can bring a different networking stack. There's a couple of different ways to do that. However, they're all a little bit hodgepodge and a bit of a mess and a bit more complicated from an operational point of view to use. So the one that we typically see when we speak to customers is where, for example, if you're running a virtual machine that needs low latency networking access, you may have dedicated network adapters in the host itself, so in that Kubernetes node, and you just pass that physical connection straight up into the virtual machine. That's a perfect way to do that today. You can take advantage of things like SRIOV. And, that's fantastic. But you've got to think about the overhead to do that. And typically, if you've got those types of use cases, there are only going to be a limited number of virtual machines that you would do that for. However, if you're not using... Go on, Dan.
Sorry. Yeah, I just wanted to point out, if you were to do that, then you would lose all of the magic of cloud native networking, which again...
Oh, you stole my point.
That's how aligned we are at this point.
I know, and that's it. Basically, if you're going to run VM side by side with your containers, why are you then trying to treat them completely different to your containers? Why would they not use the same networking and security and observability layer that you have for your containers? Why would you use something different for the virtual machines? It kind of makes no sense, other than you're just sharing the hardware that they run on from that point of view. But ultimately, this is kind of in the KubeVirt project. This is a baked-in issue. There are lots of improvements going on in the project. So you will see this from the Red Hat side. You will see this from Isovalent side as well. So we're introducing something called Netkit coming out in our next release. So Netkit will actually collapse a lot of this, where the CNI connects directly into the virtual machine. That will make life a lot easier. But for today's problem, when you're migrating a virtual machine, the issue is you lose the ability to configure the networking here. So one of the things that you can see is this says configured by DHCP. But this DHCP is provided by KubeVirt, and you have no control over that. You have a limited amount of control. I'll retract that a little bit. And that becomes a problem when you want to move the virtual machine from your legacy hypervisor on its known networking that it's communicating to all the other VMs and the firewalls and the security devices, and the identity is its IP address. When you move it into KubeVirt, all of a sudden, none of that exists anymore. That networking is completely abstracted away from that virtual machine. And that's typically where most migrations die. For any of you that are watching today and are coming from that legacy traditional background, I wrote a blog post on learning KubeVirt, and it's more just about mapping those concepts from VMware into KubeVirt and so forth as well. So you can go ahead and kind of read that for anyone who's kind of taking that a little bit of a first step in. It's also really great if you're a Kubernetes person that's been asked to run virtual machines, and the people you're dealing with who were running virtual machines come from the VMware environments as well, because you can kind of just map all of that together. Okay, so where do we fit into this? So at Isovalent, we have something called the Isovalent Enterprise Platform. It's the overarching solution of our products together. We have a number of areas that we focus on, and ultimately we're agnostic in terms of where you would run and use our software from a cloud native point of view, or if you're looking at our security software, we can run across kind of any Linux device that you can put your mind to as well, powered by eBPF. We are very much like Red Hat. We build on the open source technologies that we contribute to as well. So we are based under the hood on eBPF. It's very foundation. That's how we do our very fancy things at the kernel level. One step above that, we have the Sullivan and Tetragon open source projects. Donated to the CNCF, but we are still massively contributing to those. And then we offer our enterprise flavors on top of that, which is the Isovalent Enterprise Platform. I'm not going to talk you through all of these slides because we're here to see technical demos and technical chat. So I'm just going to move on a little bit.
Yeah.
We have 4 main products, and the area that we're going to focus on today, so you will all kind of know and love and have come across Sullivan in the past, our enterprise equivalent of that is Isovalent Networking for Kubernetes. You might have come across Tetragon in the wild, eBPF-powered runtime enforcement and observability. And I keep promising Jonny we're going to come and talk about that at some point. Our enterprise equivalent of that is runtime security. We've then got a load balancing capability, high-speed, scale-out software-based load balancing. And then finally, the piece that we're here to talk about today, which is the networking for virtualization components. This is built on top of that core networking for Kubernetes, extending that out to solve those problems we've talked about with KubeVirt and those other areas where you're migrating from more legacy environments into a cloud-native environment running containers and virtual machines side by side. So I think we've kind of covered some of these customer challenges already in kind of that opening conversation, which is fantastic. When I speak to most of our customers today, and we think about especially on-premise platforms, typically looking at the Red Hat side of things, we don't really, come across other areas as much. Red Hat's kind of the one that everyone wants to use as an enterprise platform because you get that full support of the whole platforms around it, which is fantastic for us. We have a great relationship with Red Hat, and you'll find our Isovalent Networking component certified as well with Red Hat OpenShift. But ultimately, the customer challenges is thinking about using Kubernetes for VM workloads. So why? You're already paying for Kubernetes today in your environments. You've got expertise there. It's modern tooling. You've got new applications being deployed to it. But you need to kind of bring virtual machines there as well for whatever reason it might be. Typically, it's because you're trying to move off that legacy stack. VM migrations, not an event. They are a methodology. Go on, Dan.
Sorry. I just wanted to again butt in here. I put my hand up like I'm at school here. I think one of the other areas, if you go back a slide, if that's all right, sorry.
Oh, if I have to.
Yeah, there we go. Yeah, you mentioned kind of Kubernetes for VM workloads, and kind of modernized tooling and things like that. I hope I'm not probably stepping on your toes again. Is kind of helping people with the user experience as well, because not a lot of people are running their virtual machines on their existing platforms through tooling like kubectl. There's not vmctl for whatever it is you may be using today. So suddenly expecting people to suddenly start managing all of their virtual machines by handcrafted artisanal YAML is going to be a massive technological upheaval for your kind of existing VM admins today. And again, shout out to tooling like OpenShift, where they've really kind of nailed the user experience to make kind of that leap from wherever they are today to kind of Kubernetes is the underlying platform, but for a lot of it, it's so abstracted away so well that Kubernetes is doing that clever magic, with KubeVirt doing the VM magic even further under the covers. But for those end users, it's still an environment that makes sense, an environment that feels familiar enough that the upheaval is kind of greatly reduced. We're talking about a lot of open source components, so you can, if you really want to, build a Kubernetes cluster, build KubeVirt, and build your own VM environment that would mirror something that exists today. But the experience is going to be very difficult to manage. As I say, a lot of YAML you'll have to manage manually and all of those sorts of things.
Yeah, shout out to Peter Kreuzer and his team on the user experience side, because we had them on not long ago, but we had them on a while, a month or so ago, maybe 6 weeks ago, something like that, where they were showing off some of the new things that they're doing within the virtualization console, and it is awesome. I didn't want to be like, oh, this looks a lot like VMware, but it's got that same kind of vibe to it though, right? Where it's like, okay, let me drill down. I've got these menus and just the feel to have a similarity between the two environments where you're going from one to the other to help just ease that burden from moving from one platform to another. I was like, man, this is well done. It's so good, and it looks good. It actually performs well, and yeah, shout out to Peter Kreuzer and his team because they've done an awesome job.
Yeah, and that makes sense from a user experience point of view. So if you remember when public cloud came along in the kind of early days, and you kind of had Microsoft go at it, and then AWS, and some stuff looked the same, and it kind of was easy to move between the two, and other stuff was wildly different. I think now as well, networking high-level network configuration, things like VPCs or cloud constructs like that, are pretty much all the same and configured the same in each of the clouds now for that reason, because it's familiarity and it reduces the burden on the end user as well.
Yeah,
Right.
Yeah, AWS really set the tone, like configuring the network, and then Google, and yeah, for sure. Microsoft Azure used to make me mad because of all the clicky that I had to do, but yeah. I'm just venting. I shouldn't say anything.
Oh,
So migrating VMs from that environment to whatever your new environment is, this doesn't matter whether it's cloud native based, Red Hat based, or just anything. But these are the things you've got to think about. It's kind of quite an in-depth thing, and I spent a couple of years really honing down on with some customers around this as well in previous role. You've got assessments, you've got dependency mappings, you've got to figure out your timelines, you've got to speak to stakeholders, you've got to do the migration itself, you've got to roll back if it fails, and then there's personnel and resources for that. And that's before you get to any kind of the technical side of it. The most technical bit you'll get to is dependency mapping. And that's before you get to the technicalities of actually making the platforms be harmonious together as well. And this is the reality that, you're faced with once you have decided you're going to move to a new platform. And we kind of always like to just call that out as an area as well. It's like, we're going to hone down in a technical area and kind of fix the migration execution point of view and make sure everything works when it comes back up. But there's all these other pieces that you need to consider as well.
Mm-hmm.
So migrations are very complex. We've talked about this. IP address is the number one problem. It's a sticky identity. Firewall rules are tied to it. Other products inside of your environment will probably reference those virtual machines via IP address rather than DNS, because DNS is always the problem. And if you can't lift and shift a full subnet of VMs and take that subnet with you into the Kubernetes environment, regardless of how hard it is to plug that into the Kubernetes environment after the fact, the network's going to be stuck somewhere. So you've got that to address as well. So what is it we're actually talking about today, Dean? Because we've kind of talked about a lot of challenges here and some things vice versa. So as I mentioned, we have had Isovalent Networking for virtualization available for quite a while now in a controlled fashion. We announced yesterday at Cisco Live that this is now generally available to all customers. It's purpose-built for KubeVirt in Kubernetes. Read that as purpose-built for Red Hat OpenShift virtualization. We've been working very closely with the Red Hat OpenShift team for validating this, working with it, and also co-working with joint customers as well. Allows you to run those virtual machines side by side. You can bring your existing networks in as private networks into a Kubernetes environment. So all of a sudden, you've got the ability to create essentially what you would just do in VMware, where you'd create multiple VLANs and port groups and so forth. We give you that availability to do that inside of Kubernetes. That's one of the key points that we're bringing here. That's great. So you can now bring multiple networks and have a way to route between them inside of the Kubernetes environment, but that doesn't solve the problem, which is the virtual machine came from an existing subnet somewhere else. And that's the area we're here to kind of focus on a little bit more today, which is the Isovalent Network Bridge. So this is a virtual appliance you deploy into your traditional hypervisor stack. It's high performance, highly available, highly customizable in terms of the number of networks that you can connect it to as well. And essentially, it's going to give you a bridge networking back to the existing VMware or other traditional environments that you have. So that when you migrate a virtual machine, although it will sit inside of the OpenShift environment, it will still transit its network via your traditional stack until you're ready to do that full cut over of the networking subnet layer or address scheme itself once you've migrated the rest of your workloads. So what does that actually look like? It's deployed as a layer 3 network appliance. It creates a bridge to where the Isovalent Enterprise platform runs on your Red Hat OpenShift environment today. And it's going to seamlessly migrate that traffic from the VMware environment over into where your virtual machine lives on that Red Hat OpenShift and back again. But one of the key things that we talked about before was if you run that virtual machine and don't connect it to the CNI, you've lost all the benefits of the CNI. That's what Dan was talking about. So now with the network bridge, because we're running this side by side on top of the Isovalent network, we get all of those additional features that you know, love, have read about when it comes to Sully. So we can implement things like network policies. We can do observability with Hubble. And And you can still do that in an address space, which is private to the location where it came from and doesn't conflict with your existing networking configuration inside of OpenShift today. Okay, so unfortunately today we do have a recorded demo. I would love to do a demo live for you, but because we're going to be migrating virtual machines, it doesn't always run to plan, and it doesn't always take the same amount of time each time, as you can imagine, for any of you that have used virtual machine environments as well. So we're going to kick off with the first video. So essentially, I'm going to walk you through this. We've got a VMware environment. I've got my Isovalent Network Bridge deployed. You can see it's just a virtual appliance. It's sat up there, happily running in the background. Go back to my VMware environment. We can see it's connected to what's called the VM network, and it's got 2 network adapters connected. I've got a pretty flat network inside of my environment, but you can add as many networking adapters as you need to this virtual machine, and as many port groups or VLANs as you need as well. We've then got my VMs that I'm going to migrate. So I'm going to shut off my finance virtual machine. I'm going to go into editing that machine in a second, because there's a couple of prerequisites in place. Because one of the things that we're going to use in the background here to migrate this is the MTV toolkit from OpenShift that's built into OpenShift when you deploy it via the operating services. And we're going to use that to migrate the virtual machine. And then in the background, seamlessly, Isovalent is just going to make that networking connection for you with very little configuration. So what we're adding here is change block tracking to the virtual machine so that we can migrate it over whilst it's running into the OpenShift environment. So that allows it to work with the cold migration services of the MTV inside of OpenShift. Once that virtual machine comes up and running, we're just going to log into it, and we're just going to do another prerequisite as well, which is configuring the guest tools when it runs inside of OpenShift virtualization. So we can see now I'm installing the QEMU guest agent, and that just means that when that virtual machine is running inside of OpenShift virtualization, it's going to get a new network adapter, a new disk, because that type's going to change. It's a new hypervisor stack that you're running on. All of the drivers and the necessary configurations are in place that virtual machine runs. And then finally, I'm just proving to you that we're just basically running a website on that VM and that we can connect to it as well. It's just Nginx running in the background. Okay, so let's look at my OpenShift environment. We're going to see, if I look at virtualization, we've got the toolkit installed and OpenShift virtualization set up in the background already. And I've also installed the Isovalent networking for virtualization as well. One of the things that I hope comes through here as well is actually what you will see from an Isovalent point of view is the configuration is quite minimal from our point of view. A lot of the work is still done in that migration side, which is provided by the MTV kit. So we're going to create a provider. That provider is going to point at VMware. It's going to give it credentials on how to contact and log into my vCenter server so that we can discover all of the virtual machines, especially that finance virtual machine that we've configured already. And one of the things I love about the MTV here is it does step you inside bit by bit of everything that you need as well, which makes life so much easier for me. Because I'm one of those people that doesn't always read the documentation before I try and do something as well.
Yeah, guilty.
Yeah. So you can see there, I'm just getting the disk. So this basically is how the disk images span up and copied across into the environment. And then we're just going to add those login credentials as well. And you can see I always get confused between American and UK keyboards because the @ symbol and the colon symbol are in different places. And I was going to edit out some of these mistakes, but that just doesn't feel very human. And in the age of AI, I feel like sometimes it's better to show mistakes and show a little bit of human side as well.
Absolutely.
We've added in the vCenter. It's going to connect, it's going to do discovery, it's going to look for a number of data stores and hosts. So that's the area you want to validate first and foremost before you go any further. we're up and running. You can see we've already got a host added. So this is the host cluster that I'm running OpenShift on itself. That's already been pre-configured for me. And now we're ready to create a migration plan. This sounds fantastic. So we're going to do a cold migration. For any of you that are interested, I have a longer video that shows a hot migration, which is when the virtual machine still is running at all times, and it's just a last-minute cutoff in the background. We're going to move it into a project inside of OpenShift called Finance, just to map to my Finance VMs. I'm going to select those two VMs before with those names. We're going to create a networking map. So this maps the VM network in the vCenter to the networking map inside of OpenShift. It's just called default network inside of OpenShift. That is the CNI network. And under the hood, it's Isovalent Networking Kubernetes that makes it possible. And then we're going to do a storage map as well. And I'm sure next week when you come on with Sully, that's what Sully's going to go into a little bit more, is OpenShift networking, OpenShift storage of virtualization. A little bit of additional setup. So you're going to see here, I'm going to leave the box ticked for preserve static IPs. So what that means is it's not going to go into the virtual machine and try and reconfigure the IP address. It's just going to allow that static IP address that's been assigned inside the VM itself to be migrated. But we're going to get a warning. And this is going to tell me that my plan may not work as expected because the static IP address of VMs uses pod networking. And that pod networking subnet may not be the same as where my virtual machine comes from, which kind of makes sense. That's everything we've been talking about. It's that key issue throughout the session today. So we're just going to wait for that migration to run in the background. Right, I can start that now. Now the validation checks have gone ahead. And we can see the migration status come up as well. And that little round spinny thing's going to get faster as I sped the video up, because this is the bit that does take a while. If I look at the migration, scroll down, we can see that it's running. We can see it's running against my two virtual machines. And if I click into that, we can actually see what's happening in the background as well. So it'll initialize, create a disk allocation in OpenShift. It'll copy that data over. It'll finalize that transfer, and then it will create a virtual machine that consumes that disk on top of it as well. So, as you can see, we're copying across that virtual machine. But so far, the best we've done is we've said to the networking side of the house, hey, use the default networking using Isovalent. I'm going to show you what happens in the background. So in the background, we've configured a single CRD, which is called a cluster-wide private network. So that comes from the Isovalent software. If I open that, I've called it VM network because it maps the network name inside of VMware. Just makes it easy for me to troubleshoot. And all we're doing here, very, very simply, when I scroll down on this bit, is we specify what our bridge is. So our bridge is called OpenShift Bridge. That's the Isovalent Network Bridge virtual appliance that I showed you at the start of this video. We gave it the route and the gateway for the network that those VMs should sit on. And then we also give it the subnet that it's available as well. And what that means when that virtual machine comes up, for any traffic we see destined for that gateway, for that using that subnet address inside that VM, it's going to then use that virtual appliance to pass it back to the VMware environment so that it can access its original networking and still look like it sits inside of the VMware environment as well. Now, I'm also going to show you the Sullivan config just to prove to you that the networking side of the Kubernetes cluster, so the pod networking, is completely different. So that is using a 10.128 subnet, whereas before we were using, I think it's a 193. something subnet for the virtual machines as well. So as you can see, we've deployed a networking appliance. It's very minimal configuration. It creates a cluster mapping back to our OpenShift environment. And then we essentially just say, hey, whenever you see any traffic from these virtual machines, pass it back over that appliance into its original destination hypervisor platform of where it came from. So we can now see my virtual machines have migrated over and it's completed. They're powered off at the moment, but they're going to still quickly power on at the end as we finalize that. And as I go into the virtual machine interface that Jonny was talking about, we are in a slightly older version, and I do apologize because I had zoomed in on this when I was recording the video, which means some of the up. That is me making the OpenShift virtualization console look bad, not the Red Hat team. But we can now see that virtual machine is running and that my finance virtual machine is available and running again. So I'm going to stop the video here just for the time on the show today, because we want to look at answering questions, and we've got a couple other areas to go through. So like I say, we've got a full video, which is Johnny's already shared the blog for that. We released that a couple of months ago. That takes you through all this end to end. The warm migration essentially keeps the virtual machine actively running. And actually, if I skip through this a little bit, what we're going to see here is we basically ping the virtual machine, and then we'll see it when it cuts over inside of the MTV configuration. It's going to time out. And then I'll skip a little bit further ahead. It's going to come back online, and then the VM is up and running again, which is this bit happening here as well. So there's always going to be a little bit of time when that virtual machine goes offline as it cuts over, because you are essentially moving everything. You're moving storage, networking, runtime, all over to a brand new platform. Unfortunately, I don't think there's any technology out there today that will do a full active migration of a VM where it never loses a ping or a connection whatsoever. But it will, it is quite kind of short for it to come up. So you see there at the end of the video, it comes online, and then the operator does a little bit of a reconfigure on the network card as well. So
yeah, that's awesome.
That piece, is this the same video? See, it does this to me every time. There we go. So the second video that I wanted to show, again, going back to Dan's point, is we've now migrated into the OpenShift environment. That's fantastic. Let's start taking advantage of some of those components that are available through the basics of Sullivan using, Isovalent Networking for virtualization. So we have I'm clicking the wrong button now. There we go. We have a component called Hubble Timescape. It's a historical, analytic, and troubleshooting tool built on top of Sullivan. We're going to look at my cluster. Inside of my cluster, we're going to look at that finance project where my virtual machines sit. And we can now see all of the networking going on, the network flows to those VMs already. That's without any instrumentation into those virtual machines or any changes inside of the environment. We just start to pick that up automatically. We can also then see connectivity from my virtual machine on the outside world, which is that WKST1-2011. And you'll see as well, it says OpenShift-bridge. And that shows that we're coming across the traditional networking to access that virtual machine as well. So we can see that that virtual appliance in the VMware environment is making this is making this connection available. So the VM looks like it still sits at its original location. I think this is where my video gets stuck in the PowerPoint, because I think this might be a bug inside of PowerPoint a little bit. Yeah, so move it on. So let's have a look at what happens inside of the OpenShift environment. So we're going to get nodes. You can see my OpenShift nodes going to get the virtual machines. They're up and running. So this is kind of the more Kubernetes user type of way of accessing all of this. I'm now going to apply a network policy to my virtual machines. This is the same type of policy that I would apply to my containers. There's no difference from that point of view. We can target using Kubernetes labels. And we're going to allow access to port 80 and 22, like we can for all virtual machines. And now inside of Timescape, I can see that policy come up. I can see that it's available. We have actually improved this UI massively as well in a release that's coming out in the next week or so. So keep an eye out for that blog post. But we can see that that policy has been added. We can see what that allows it from a visual point of view. And I can edit that in this view as well if I wanted. What we're now going to do inside of my environment is I'm going to connect into the virtual machine, and I'm just going to prove that that connectivity using that policy works. And then we're just going to show that as allowed traffic inside of Timescape as well. So if you remember, we allowed Timescape. We allowed SSH to this virtual machine, and we also allow port 80 access as well. So we can still access that website that runs on that virtual machine. Okay, yep, so we've logged into SSH Works. I'm still coming from my local Windows machine that we could see the connections from before, and I showed that that was going across that network bridge capability. And then if I remember correctly, yeah, I was trying to kill from inside the VM and realized that was a mistake. I needed to exit the SSH session, then kill from my local machine just to prove that that website works. So there you go. We can see we get a HTTP 200 there. And then when we go back into the Timescape interface, we're going to see that flow and my access is still working as we expected. So we can just see that coming up on these bottom flows here as well. So I'm just going to skip the video along a little bit, just again for brevity of today's session.
That's super nice.
So now what I'm going to do is I'm going to go in, I'm going to break this network policy. So I'm going to make an update, but I'm going to fat thumb it like we all do at times. I'm going to change that to port 23. And as we all know, port 23 is what protocol, Dan?
Telnet.
Way, it's Telnet. So we're just going to check that that CMP has updated inside of my environment. So you can see we've just got the one there. And let me go back. I'm going to skip all. Yep, so you can see it's there. We go back into our Timescape interface. We can now see Timescape has captured an updated policy, and it gives me a differentiator of what that was. So the green is what is now active, and we can see that it's 23 as well. So from a troubleshooting point of view, I can spot that I fat thumbed it. Now when I try and SSH to my virtual machine, we're going to find it breaks. And if I go back to my flows page, in a second, we're going to see it pop up. I'm going to reload it to do on dropped, but it will show if I left it long enough. We can show that it's blocked as well on port 22 for SSH. So using Timescape, we can view all of that networking traffic that we've talked about every time. One of these days, I'll be able to use PowerPoint without that problem. So from a use case point of view, what we looked at inside of that video was migration. So we can do a full migration, migrate everything off VMware. You're going to remove your VMware environment and you're just going to run your VM side by side. And we have methodologies to cut that off, and we get rid of the network bridge. And Johnny's going to put some links into our GA announcements from today that I sent to him earlier on from yesterday's Cisco Live, and that talks about kind of like how we connect using things like BGP and EVPN to like advertise those VMs out through your Kubernetes network. And through the private networking point as well. You can do a partial, so if you're not ready to fully migrate off VMware, but you need to move some of those VMs, we can offer that too. We can then do things like security policy and security policy migration. So if you're moving from NSXT, for example, we can migrate policies over, and network visibility through the Timescape piece, which we've shown as well. And we're using all that same construct for Kubernetes environments that kind of we know and love. And then finally, this was my last slide for today. And I just thought it was kind of really cool to kind of show you where we've come from since August last year, where we offered our first controlled availability to a select number of customers, to GA, which was yesterday as well. And there's a lot of features on this slide that we've not even talked about, such as the EVPN and the distributed access to and the multi-NIC support for virtual machines themselves, that no doubt we'll come back and talk about in the future. And Johnny, I'm going to call you out and ask if there's any questions that me and Dan need to answer.
Yes, there's one. It's from, and I'm sorry, it's Khalil HBDS. So if I've butchered that, I apologize. Does the Isovalent network bridge completely eliminate the need for Multis when migrating VMs, or do we still need Multis for secondary interfaces alongside Isovalent private networks?
Yeah, fantastic question. So with the support that we have for multi-NIC support here, as generally available from yesterday, you don't need Multis. Essentially, you just can edit the YAML of your virtual machine and attach multiple NICs from those different, same or different private networks as well. So if you've got a tiered setting of different kind of like, I always like to think of it as VLANs. Private networks don't have to be tied to VLANs from that point of view, but a lot of times because of VLAN separation, you need that. You can do that. So that capability is fully taken care of. If you have a need where you still need to use Multis today because you want to expose maybe the direct host level networking, like a NIC that is in the host direct to a virtual machine, side by side to a second NIC that is to the CNI, that's also doable. It becomes a little bit more complicated from a administrative overhead point of view. But, you know, we are happy to sit down and talk through those use cases with you as well.
Yeah, awesome. So I pasted the links, and what I'll do is I'll update the video descriptions with all the links that we've shared today. But that was the last the last big question. The other ones are more about like developer subscription and sandbox stuff. So
yeah, fantastic. So, if any of you are already working with Cisco or Isovalent today, in any capacity, you can get in touch with us and we can kind of help you test, trial this, show you live demos inside of our environments of this as well. We have a number of customers that are using this actively today as well. And we're continuing to build it out with Red Hat in terms of those capabilities going forward. Dan, is there any area I didn't cover through that video?
No, I think that's. I mean, yeah, I think it's just understanding the bridge. You have the beginning of a bridge, the end of a bridge. One part of the bridge exists within your existing environment. The other part of the bridge exists in your new environment, and magically that bridge will take care of traffic going where it needs to go once virtual machines have migrated. And then you get all of the magic on top of all of that from the VMs now living inside the Kubernetes cluster. So I think, my only other question, I suppose, was if you'd have put port 21 instead of 23, what protocol would that have been?
21. Is 21 SMTP?
Nope.
No.
Oh. Wait,
Dude, when you said 23.
Yeah, SMTP's 25. Oh, it's 21.
Ticking, clock's ticking.
Oh, no, it's gone. It's gone. I will be forever confined to the doldrums of networking, and they'll take my seat.
It ends with TP. That's FTP.
FTP, of course. God damn. Can't believe that.
Dude, when you said 23, I was like, I could not remember.
Yeah, so the audience got it. Amazing.
Fantastic. Brilliant. And Mr. Hope, who I've seen messaging there, yes, we have not spoke for a very long time, but it's nice to see you pop up with a comment as well. So, hello.
Yeah, our Hope 9, man, he's the man, the legend. So what's next for you guys? Like, because I'll be honest, like the Timescape thing, that looks awesome. Like, I love that. And then having like the Git review type of like, hey, here's the change on the the interface or whatever. I think that is freaking awesome. Like, I love the way that is, because I've just been in that boat where you're trying to debug what's going on, and to have something just kind of like stand out like that, I think is really nice.
Yeah,
it's like a TiVo for network policy. Just like go back to where it was working.
Yeah, exactly. It's awesome.
Yeah, so that's the area I work in quite a lot. It's one of my favorite things inside. Maybe I have to say that because I work on it, but there's so many enhancements coming out in our next version in the next week or so that I've been writing about as well. I can't wait to get out there because it's just on steroids in this next release in terms of what you can do in that interface, which is really cool. If you go to isovalent.com/labs, we've just on Monday released a GitOps lab that is showing how to use Cilium in a GitOps world. So how you do network policies, but how you can allow your application teams to write their own network policies and then use our tooling to lint and validate and simulate those policies before they're applied to a cluster, and then use Timescape for your application teams to troubleshoot network policies as well. And that's a really cool use case. One of my favorite customers is Adobe, because Adobe allow their their internal app teams to write network policies, and they basically have it all linting through Git and through work validation stuff like that. So people can't, for example, like me, come along and do port 23 for Telnet by mistake. Their linting system will stop it from happening. But it means a network security ops team doesn't need to sit there in that review path and kind of check every single addition to a network policy that an app team is putting in place. And the app team don't have to wait for a network team to review it. Of course, we're going to spend probably the rest of this year talking about how to make VMs migrations successful, especially into OpenShift environments. I think, there's so much noise from customers and potential customers around this. Like I say, this was the one thing we spoke about at our booth at Red Hat Summit. We went and then spoke on one of the Red Hat Summit stages about this as well. It's vice versa the same at Cisco Live this week in Las Vegas. Red Hat are there at Las Vegas. Marcos is on the Red Hat booth as well, talking about this, as well as his own booth talking about this. So yeah, I expect this to be probably a conversation that lasts into the rest of this year.
Yeah, for sure. So we got a question from Doc1929. GitOps approach is more for cluster administrator or app deployment?
Yeah, go on, Dan. What do you reckon?
Well, I mean, this is the point. I suppose in terms of the example we've shown today, you can use GitOps for any sort of example. We're managing kind of the manifests that are in the cluster. Now those manifests can point to virtual machine infrastructure, as opposed to my application is based upon this deployment, this service, this whatever. So yeah, I mean, commit some VMs as YAML to your registry and have kind of that pipeline go and deploy things as expected. That's the idea and the hope with having a cloud native approach, kind of doing all of those sorts of things.
Yeah, so John's going to share my screen again. So this is the lab. You can go to isovalent.com/labs, or you can browse it at the top to all labs. And it's the first lab that's there because it's the latest. And you'll see who is it for. So we're going to look at, day one without any guardrails. This is just a Kubernetes cluster. Anyone can access it. Who breaks stuff? Who can access stuff? What problems that can cause? We're going to use open source tooling like Converno. We're going to use open source tooling like Argo CD. We're going to then look at Kubernetes Sullivan features such as Gateway API. We're going to look at ISO policy, which is a tool from Isovalent to lint and validate policies. And it does a really cool simulation feature. So it will take a network policy, look at your previous flows in a cluster, and then tell you based on those previous flows whether that policy will affect the traffic or not, whether it will allow additional traffic or deny traffic. So straight away what's going to happen. And then we're going to look at it from an application team point of view. So you can then, as an application team, understand how to use these if you're just, hey, going to deploy my application, but I also get some additional access where I don't need to go and open a ticket with the platform team, open a ticket with the security team. My workflow becomes a lot more streamlined. And then finally, because everyone loves some sort of certification validation, a number of our labs have badges available through the Credly system. You have a little exam that you can complete at the end of that if you so want to. But our labs are public, they're available. You just need to give us a couple of details and you can access them. And I think we've got 30 plus labs available now across all sorts of different features and so forth. And I know Red Hat labs heavily used because I used to use them as well. Pretty much the same. I think we use the same system as a back end for the same labs as well, which is fantastic. So the user experience for anyone watching today who've done labs with Red Hat will have the same user experience in our environment too.
Yeah, that's awesome. And I was going to say, like for the question about GitOps being like for cluster admins or applications, it really just kind of depends on what you're doing. GitOps is it's for both, right? And I think that with the right implementation, it can be for both, right? Your cluster admins can manage the cluster and cluster resources, and then you as an application developer can also just manage the resources like network policies or VM definitions, Cilium definitions, whatever it is, right? Just using the same tooling. So it really just depends. Let's see. So Khalid HPDS, so have you ever worked with a client or partner who needed to build their own custom MTV provider for a niche or unsupported legacy hypervisor? I have not. I'm actually looking through the documentation right now. I was going to say, if you want to email me a question or email me your question at johnny@redhat.com, and I'll try and find out. I'll let Dean and Dan take a shot at this as well.
Yeah, sure. I can kind of go through this.
So if we don't answer your question completely, feel free to reach out to me and I'll reach out internally and get some docs for you. So yeah, go ahead.
So MTV, Migration Toolkit for Virtual Machines, like everything, is built upon layers upon layers upon layers. So MTV is built upon something else called Forklift. Forklift is then built upon another tool which is called Virt-V2V, which is a pretty old tool which was designed to convert from VMware, Xen, Hyper-V, and a couple of other hypervisors to migrate them to KVM. Now, in order to effectively grab an existing virtual machine, the hypervisor that you're wanting to interact with needs to expose a bunch of functionality for you to do that. So typically with VMware, for instance, you are continuously taking snapshots, coalescing those snapshots, and building a copy of the disk somewhere else. Eventually, you get to a point where you can then stop the virtual machine, know that your snapshots are up to date, turn that virtual machine off, and you've got a copy of the virtual machine somewhere else. Typically, there is another technology called stunning. So you stun the virtual machine, which slows it down so that your snapshots aren't, it's not creating so much data that you never end up in a position where you're continuously snapshotting, and you can then stop copying. So really, it's a case of understanding what it is required to grab a live disk from somewhere else. And two, does that hypervisor support the capability to do those operations, as I say, grab snapshots of the underlying storage and to stun the virtual machine. Sorry, there's a massive storm erupting outside right now. Stun that virtual machine in order to ensure that the deltas are eventually shrink enough for you to copy that disk and then stop the virtual machine as you're copying it. But all of this is all open source. So Forklift is open source. Vert-V2V is open source. I don't know which hypervisor you may be thinking of. Maybe that is open source, or released talks about the APIs that it exposes in order for you to do those sorts of things.
Yeah, it's a really interesting one. I worked quite heavily with migration technologies in my previous role, and very migration tooling, because there's a lot out there, and there's even a lot offered by the likes of VMware over the years. You've got things like VMware vCenter Converter, I think it was called, or vConverter probably. You've got HCX and stuff like that, and those things Dan talked about, being able to contact the disk, take a snapshot, how then it moves those storage blocks over into your new system and puts them in the right format for KubeVirt or whatever, other technologies in place is kind of really key. A lot of customers ultimately who look into this in depth are only going to migrate the virtual machines they need to migrate and leave the rest of the virtual machines to just age out and die. If that virtual machine's got a lifespan of 3 years and it's 1.5 years through its lifespan, it's probably going to take you more than 1.5 years to migrate all of your VMs anyway. So just let it die. And when it's finished, deprecate that VM, spin up the new services on your new environment, whether that is a new VM or a new container service. Don't move all of that legacy. You don't need to move absolutely all of it. But these types of solutions are available to move the workloads that are really meaningful that you do need to keep hold of. So yeah. And Dan, you wrote a hypervisor in eBPF as well once.
I wrote a layer 2 switch in eBPF. I wrote a hypervisor in Go. But yeah, so one of the things I wanted to do was understand kind of how all this hangs together. So yeah, it's actually less complicated. Well, it's not true, really. It's certainly not as crazy as you would have thought in order to actually stand up a virtual machine. There's a lot of examples out there, but if you can't sleep one night, it's certainly something to sit and read through, reading all the IO docs and things like that.
All right, awesome. And then we have one question from Doc1929. They say, it confuses me when using OpenShift because there's also ACM policies and I don't know which one to use. They achieve the same goal. So they are very similar, but the thing to remember about ACM is it's Advanced Cluster. For those that don't know, ACM is Red Hat Advanced Cluster Manager for Kubernetes. It's a lot. Why? But so ACM, it's a full service platform, right? It does way more than just deploying policies. So you can actually use policies to achieve a GitOps approach to application deployments. There are projects that use ACM policies specifically just to manage their GitOps workflows. Argo only does GitOps, right? And I don't mean it to sound negligent or anything like that, but it's or disparaging. But it's an Argo. It's a GitOps platform. It's a continuous delivery platform where ACM is a full-on lifecycle management platform. So it does cluster lifecycle, so it can provision, destroy, hibernate, all kinds of things with clusters. But then you can also manage applications on those clusters. So it is so much more. If you don't have ACM, then you can use GitOps to do a very similar thing. Well, application deployment. If you have OPP or the OpenShift Platform Plus subscription, or you have an ACM subscription, then yeah, 100% you could totally use ACM to manage your GitOps platform. They do similar things. They handle it in a different way. Like the ACM policies are just a slight bit different, but Yeah, the idea conceptually GitOps is the same, but yeah, just the tooling is different. Let's see here. Yeah. And R Hope 9 says lazy sysadmin pick applicable one. Yeah, so yeah. Awesome. So Dean, Dan, guys, really appreciate you guys coming on. So you're mentioning the storm, and I can see the clouds outside. It's like it's starting to billow up here as well.
Do you know what? If you actually look where we live on a map now, the three of us live in a triangle, and it will be the storm around that triangle now. Because as I started this call, I was having the bad weather here.
That's just followed us around. Yeah, I love that.
Yeah, it's crazy, and it's been really, really nice lately. I mean, like the weather, except last week it got really hot, which is funny coming from me being from Texas, but it was hot last week. It was miserable.
I'll build for it here.
Well, dude, no aircon, man. That's a real thing. But yeah,
I've get to see it in this country at least.
Yeah, hopefully one day. But no, I appreciate you guys coming on, and thanks for taking the time, Dean, and thanks for reaching out with all the new stuff that you guys are working on. Always welcome back. You know, like we love having you guys on. Dean, we go way back now at this point, and it's always a good show when you come on. So yeah, if you ever want to come back, let me know. And then I'll post all the links to the things that we've talked about today. I'll put those in the show notes so that way everybody has access to them. Yeah, and while I'm getting everything ready, if there's any last words that you guys want to say, go ahead.
From me, thanks very much for having us back again. Really enjoyed it.
Yeah, completely echoing Dean's comments. You know, as he mentioned, all of the labs, I'm not taking credit. It's a lot of Dean's work doing all the labs, but they are a phenomenal resource for getting clusters, getting access to some of the things we talked about today. So, like, yeah, if you want to learn more, that is a fantastic place to get going. Yeah. So again, thank you.
Awesome. Thanks, guys. Yeah, and seriously, check it out. They want to know, they want feedback, they want to hear how you're using it, when you're using it. So if you are and you're running into, if you get good, bad, or indifferent, they want to hear about it. So yeah, go check it out and learn. And yeah, awesome. Next week it'll be me and Sully again. I think we're gonna deep dive into storage. We could do some more networking, but it's looking like it's gonna be storage. So yeah, until then, take it easy.